geometric series is the sum of the terms of a geometric sequence. There are two types of geometric series: the finite geometric series and the infinite geometric series. The finite geometric series represents the sum of the finite number of terms of a geometric sequence, while the infinite geometric series represents the sum of the infinite number of terms of a geometric sequence. To determine the finite geometric series, use the formula S sub n is equal to t sub 1 times the difference of 1 minus r raised to n all over 1 minus r, where S sub n is the sum of the first n terms, t sub 1 is the first term, r is the common ratio, where r is not equal to 1, and n is the position of the last term. While to determine the infinite geometric series, use the formula S sub infinity is equal to t sub 1 divided by 1 minus r, where S sub infinity is the sum of the terms, t sub 1 is the first term, and r is the common ratio, and r is not equal to 1. In an infinite geometric series, when the common ratio is between -1 and 1, the value of r raised to n decreases and converges to 0. However, when r is greater than 1 or r is less than -1, the series diverges from 0, meaning its partial sum increases or decreases without bounds.
Let us now get the sum of the first term of the geometric sequence 2, 8, 32, 128, and so on. We are going to determine S sub 9, or the sum of the first 9 terms. Now, since the number of terms to be added is indicated, we are going to use the formula for the finite geometric series, and that is S sub n is equal to t sub 1 times 1 minus r raised to n all over 1 minus r. Now, let us identify now the needed value. So, t sub 1 is 2, it's 2. T sub 1 is 2. The common ratio is 8 divided by 2 is 4. Then n is equal to 9 because, again, we are going to get the sum of the first 9 terms. Substitute now the values. We have S sub 9 is equal to 2 times 1 minus 4 raised to 9 all over 1 minus 4. Then simplify the given equation by following the order of operations. So, copy first 2, and then we are going to perform the operations inside the grouping symbol. So, we have subtraction and exponent. So, we are going to get first the power of 4 when raised to 9. So, 4 raised to 9 is 262,144. And then subtract 1 and 4. So, 1 minus 4 is -3. After that, we are going to subtract 1 and 262,144. So, S sub 9 now is equal to 2 times -262,143 divided by -3. And then we are going to multiply 2 and -262,143. So, that is equal to -524,286 divided by -3. So, negative divided by negative is positive. So we have now negative 524,286 divided by negative 3 is equal to 174,762. So this is the sum of the first 9 terms of the geometric sequence 1, 2, 32, 128, and so on. For number 2, we are going to find the sum of the first 7 terms of the geometric sequence when t sub 1 is 2 and the common ratio is negative 2. Now, since we are going to determine the sum of the first 7 terms, that means our n is equal to 7. And since it is indicated, the number of terms to be added is indicated, we are going to use the formula for the finite geometric series. And that is S sub n is equal to t sub 1 times 1 minus r raised to n all over 1 minus r. Let us substitute the given value. So S sub 7 is equal to 2 times 1 minus negative 2 raised to 7. Then 1 minus negative 2. So S sub 7 is equal to 2 times 1 minus negative 2 raised to 7 is negative 128. Then positive 1 minus negative 2 is 3. Let us proceed to the next step. So S sub 7 is equal to 2 times 1 minus negative 128 is 129. Copy 3. So S sub 7 is equal to 2 times 129. That is equal to 258 divided by 3. 258 divided by 3 is equal to 86. Now, let us proceed to the last example. Find the sum of the geometric sequence 27, 18, 12, 8, and so on. Now, since the number of terms to be added is not indicated, that means we are going to use the formula for the infinite geometric series. Again, the number of terms to be added is not indicated. So we are going to use the formula for the infinite geometric series, and that is S sub infinity is equal to t sub 1 over 1 minus r. Now let us identify the needed value. So t sub 1 is equal to 27. R now is equal to 18 divided by 27, and that is the lowest term of 18 over 27 is 2/3. So substitute now the values. S sub infinity is equal to 27 all over 1 minus 2/3. So 27 over 1 minus 2/3 is 1/3. Now that technique here, when subtracting a fraction from 1, is that just subtract the numerator from the denominator and then copy the denominator. So that would be 3 minus 2, 1, and then copy the denominator, which is 3. After that, we are going to divide 27 by 1/3. So to divide fractions, you need to get the reciprocal of the denominator and multiply it to your numerator. So we have now 27 times the reciprocal of 1/3 is 3. So 27 times 3 is 81. So the sum of the geometric sequence 27, 18, 12, 8, and so on is 81.
Now it's your turn. Answer the activity and what to do to practice your skills.